So now that you have a GCP account set up, you've set up your client tools, and you have at least taken a look at IAM role security, it's time to start working with files and data. So in terms of the reference architecture for bioinformatics analysis, the sections we'll be looking at here are using cloud storage buckets, and that's where you're going to usually store your input sample data, your reference data. Also put your analysis results, usually go out to a different bucket. There are other types of data services that are available for relational data, like traditional MySQL databases, and that's in Cloud SQL, so that's included here. And then there is a service that is really, I find really frequently used actually by researchers. It's serverless SQL for analysis. It's kind of a mouthful, but basically you write SQL queries and they're run not on data in tables, but data in files. And those files can either be in cloud storage buckets or they can be in BigQuery storage itself. And what I've done is I've written one-page explanations of these data services here in this section. And we're going to start by looking at cloud storage, which I'm sure basically all of you will use. So let's go in there and take a look at that. And the concept is buckets. So basically you want to put some of your research files up on the cloud so you can perform analysis, and you want to organize them. So you're going to use buckets, and you can use folders within the buckets if you want to, but there's also other ways that you can organize by basically adding annotations. But before you do that, there are some key considerations. So it's really important to understand, particularly for bioinformatics where you can have a lot of files or very huge size files, you want to pick the right configuration for your particular need. So first of all, you need to understand that storage costs differently depending on the type of storage. It's called storage class. The default is multi-regional, which means that it's going to be copied for you automatically across multiple physical data centers, which is great for making sure that the data is available if your research team is global, for example. However, it can cause you to incur more costs than you might want to because you do have other options. You can use, for example, regional, and that would mean that your files are stored in a specific region. Now, of course, that might not only be for cost, it might be for compliance as well. And then there are additional storage class types, nearline and cold line, which you can think of as archival or keeping for regulatory compliance, but you probably don't have to access them frequently, and they're much, much cheaper. So this is an area that I find that I can help customers to make good choices and spend their money more effectively if they think about their use case and they set up their buckets correctly. Subsequently, you want to, once you figure out where you want to put your data, the way you'll actually do this is in the console, or you could do it with command line, but we're going to do it in the console. You're going to create a bucket object. It has to have a unique name, and then you're going to set a storage class, and here I'll show you. So you can see by default you have multi-regional as the default, and then you're going to configure other options for the bucket. Now notice Google actually tells you here what the storage cost is. In addition to the storage cost itself, you also need to think about the cost of ingress and egress, putting the data into the Google Cloud, and if you for some reason need to take it out. As you might expect, it's more expensive to take it out because Google is very happy for you to have it in there. So you're going to want to look at the pricing, which I've linked here, and kind of consider costs when you're doing this. I also have a link to the key bucket operations. Very quickly, this is a type of a process that you'll start by using the console, but you will tend to script this using the client tool, which is GSUtil. It's the G-Cloud service, basically, that you use to script. Also, it's really important that you set permissions properly, and there's been some recent changes to the capability here. So you can set the permissions at the bucket level, or you can set at individual objects, which means like you could restrict some of the files with different permission settings within a bucket rather than just all files in the bucket. Also, Google now has the capabilities so you can manage your encryption keys. Data is encrypted by default on GCP, both in transit and at rest. But for some scenarios and some customers, particularly around health data, they need to manage their own encryption keys. And again, your organization will have these policies in place, so you just need to talk to them about it when you're working with actual personal health data. So once you've done this, then you just want to look inside your bucket, and there's a screenshot of what it looks like. Also, I'd be remiss if I didn't mention, because I do see this frequently, as I say here, storage can be the most significant GCP service cost due to the number and size of files. So in addition to getting the best storage class, you really want to think about a file archiving process, moving the data that you're not accessing frequently to a cheaper storage, nearline or cold line. You can actually do that automatically. You can set up a policy. And just the really common sense, deleting files that are generated during your processing. There are many bioinformatic type of tools that generate intermediate files that oftentimes you don't need after your analysis is over. So it's going to depend on, of course, what kind of analysis you're performing, but this is just a pattern that I see over and over. Again, I've linked to best practices, and because I know some of the research groups like to host websites, you can actually host a static website really simply out of storage as well. So let's actually look at the console and see how this works. So I've actually created a bucket here called Variant Spark Data for an analysis that I'm doing with a group in Australia, CSIRO Bioinformatics. Their tool is Variant Spark. So again, you want to give your buckets intuitive names, but they have to be globally unique. And you can see I've uploaded a couple of files here for a demonstration that I do with this library. And you can see that I've made them public. And to do that, you simply set the permissions for all users to be able to read. So if I go into the bucket here, I go back to the level of the bucket, and I click on the bucket, you can see that it's telling me this is public. And this is important because this is not something obviously you would do other than for a demonstration. And in here I can edit the bucket permissions, and you can see that I can set up different members inside of here, and it's giving me again this highlight that it's all users have been set up that they can read this. Notice also you can assign metadata here. This is labels, and this can help you to identify. So for example, if you're working with grad students and you want to give them a bucket where for the duration of the time that they're working with you, they can put their data, and then you can identify that when they leave because it's labeled with their name or their school. That can be really helpful in terms of managing data. It's just a real simple thing, and that's what it looks like there. So in terms of creating a bucket, if you want to create a new bucket, you pick your global name here. So demo for, let's see if I've used this one before. I might have to say that to make it unique. And then the next thing that you would do is choose your storage class. So multi-regional, regional, nearline, or cold line. And notice that there's some regional capability here for the different areas of the world that can help you with compliance needs, particularly Europe, you can see. Then you are going to set your access control. So this is really important to think about the use of your data, if the permissions are going to be set at the bucket level or if they're going to be set differently on different objects within the bucket. So we'll just do this. And then notice we can use the Google Managed Encryption Key by default. We could alternatively use our own key if we had that requirement. Notice here we have a retention policy, and we could set a retention policy. We could retain objects for a certain amount of time, all objects, and let's put this duration in here. So 1 day. And then we can redirect where those objects are stored to save money on storage costs. And here we would add labels. Notice to the right here, we have some pricing information that can help us out depending on, how much data we're putting in. So let's put this amount of data, and you can see the data retrieval. Right now, we're doing this much. And Class A operations, we're doing that much. In class B, we're doing that much. And you can see now we have a monthly cost estimate. So these, again, are just estimates. Your cost, of course, is going to be generated on what you actually do, but it really helps you to understand storage costs, which is a key aspect of using GCP properly for research.